uh, we are given a list of intervals in here and a list of intervals in the second one, two different lists, and then we need to return the intersection of it. So if you take a look at this one right here, for example, the intersection of 1 and 3 interval with 2 and 4 is 2 and 3. That's where the intersection is occurring. So if you take a look at this picture right here, so at this interval, with this interval, at this part right here it overlaps, so we will be recording it in our output. So let's solve this problem. So we will, the way we're going to solve, since we have two lists this way, we can actually use two pointers, and the one will be pointing to the first list, the one will be pointing to the second list, and then from there we will check if they overlap or not, and then depending on that we will be shifting the time which is lower. So let's say this one is smaller than this one, the end time of it, then we will shift to the right, same as for the second list. So, and then we will be adding everything to our final list. So for that one, let's create a deck integer. This will be our intersected list, new array deck. Then what we are going to do, so you can use deck or list, it doesn't really matter. Let's do list in here, array list. So we will be not using the fancy API of deck, so array list should do it. Now let's create our two pointers, which will be initiated, both of them at 0. And let's go through it until I is smaller than the first list length, and j is smaller than second list length. So how are we going to check the overlapping of it? So for the left side of the interval, we'll be getting the max of first lists 0, and so first lists I, and then second lists j's 0. And for the right side of the range, we'll be taking the minimum of the first list i's 1, the second, the end part of it, and the second list's j end part of it. So from here we'll check if left is smaller than equal to right, because like we can see that when we have 24 in here and then 24, when they overlap, we're also returning this saying this was overlapped. So intersected at this left and right range of it. Perfect. So now we need to increment the time. So if let's say in the first list ith, the end time, if it's smaller than the second list j end time, that means if the end time of the first list is smaller than the end time of the second list, we want to move right of the first list, so I plus j, I plus plus, else we will move our second list. In the end, our intersected list will contain the final result, so we will just return it intersected to array, and this is two-dimensional. We'll just need to give the intersected. In this one, the way the internal it works, we would need to define the row, but in this case we can just choose 0 because internally this is most optimal. So let's run our code. Perfect. Let's submit it. So the time complexity in here is O(m) plus n, where m is the length of the first list, and then n is the length of the first list, and the m is the length of the second list. And space complexity, we're not counting output of it, so here we're just like using some temporal values. It's not growing by our runtime, so it's all of 1 constant.